biostatistic work, most of it. Okay. Alright, so I think most of you already know this. Greulich and Pyle method, where the scientists Greulich and Pyle obtained radiographs of 1,000 medium-high social class white boys and girls in Cleveland, Ohio, USA, in 1931 to 1942. So it's almost 90 years in existence, okay, where the first X-ray been taken. So at that time, from this 1,000 radiograph of the left hand, they produced 31 male and 27 female radiographs to be used as an atlas to predict skeletal age, to predict actual age. So it illustrates the different phases of bone maturation between 0 to 18 or 19 years old. Okay. Sorry, this method is still relevant until today because it's the most widely used method, Greulich Pyle method, because of its ease of use, reliable, and had undergone many validations throughout the world and since 1950s. So they actually have two editions, 1950 and 1959. Okay, so in the first edition, many of the couple bones have not been named yet. So that's how old is it? Okay, so why this research was conducted? So first, to estimate the actual age is very important, using from the left-hand radiograph, because forensic determination of childhood status carries important legal ramifications, particularly for refugees without appropriate documentation. In Sabah, this issue is even more pressing due to rampant unresolved statelessness problems. Other possible medical application of the JP Atlas method include providing independent age estimates for criminal trials and immigration purposes. So, however, despite its apparent usefulness, there is limited data on the accuracy of JP Atlas in Southeast Asian countries, and particularly in Sabah, where it is most direly needed. So, the research objective was to assess precision of Greulich Pyle method in estimating chronological age in children in Kota Kinabalu, Sabah. Second is to assessment of the accuracy of this method. Okay, so when you talk about trying to predict the actual age using left-hand radiograph, you are actually concerned about the precision and also accuracy. So what does it mean? Precision means how often the prediction will predict the same thing. For example, if I take 10 of you, I teach you GP method. So how closely related the 10 of you will predict the same thing? So how closely the prediction will be together with each other. Accuracy means how close and how near your prediction to the true value, which is the actual age in this case. Okay, so as mentioned here, so high accuracy means high precision. Although it's not accurate, the estimation is centers around the same place, so they are very precise. So this is statistical term, precise. And high accuracy means the prediction is near the true value, which is the actual age in this case. Alright. So if you have high accuracy and high precision, what you predict is actually very near to the true value. And highly precise means if I take 10 of you, 10 of you will say the same thing. If the method is wrong and not accurate and high precision, 10 of you will make same prediction, but all of you are getting it wrong. This is low accuracy, high precision. So this is what are the two things that we want to know by doing this study. These are the two research objectives. So the methodology, study design was a prospective observational research we conduct in the 2021 and 2022, recently concluded. So the inclusion criteria was age 9 to 18 years old, no history of congenital abnormalities, no significant illness, no history of fracture to the left hand, no soft tissue abnormalities, normal clinical findings upon examination. Image acquisition is very standardized of left hand radiograph using 46 to 50 kV, 2 MA, standard distance of 100 cm, and subsequently identified. So we changed we closed the identification, we blackened out, and then we de-identify. So we do not know the name, and also we do not know the age. So when we give to the radiologist to identify, so this bone age estimate using the GP method given to 2 experienced radiologists working at the Greulich Children's Hospital, and they do not know the age of the children. So they try to estimate the bone age, whether can it predict the actual age. So the results, 182 kids were enrolled, 79 of them were boys, and 103 girls. So the mean age of the 182 kids were 13.9 years old with standard deviation of 2.4. And 79 boys is about 14 years old, and the mean age of the girl is 13.6. So first we look at the precision. So the common statistical method that we use all over the world is we are using intra-class coefficient, where we calculate overall ICC of 0.937. So these are the, how do you interpret 0.937? If you have ICC of 0.921, it is excellent agreement. Means if I take 10 of you predicting using GP method, predicting an actual age using the bone age, all of you will get the same thing by using the GP method. So this is very high ICC, 0.937. So we look into the difference between point angles, it's about the same, 0.947, 0.93. So it's very high, very precise. So if I turn 10 of you will give the same answer because it's very precise. This method is very precise. So it has excellent inter-rater reliability with regard to precision. So we look also in another statistical method of Pearson correlation. So Pearson correlation showing very good, significantly correlated between each other, 0.8 and 0.72. Okay, so that's about precision. Now we go to the accuracy. So in the classical teaching of biostatistics, we take the mean age of all the children. That's overall 13.9 years old, the mean average of the age. And then we also take the mean average of the prediction age, 13.2 age. Okay, then we see the difference of between the prediction of the age and prediction of the actual age. Okay, so this is the mean of all the 182, and this is the mean of all the 182 prediction. And then the estimation of actual age using GP method by using the classic biostatistic teaching is they underestimate the actual age by 0.7 years, which is about 8 months. Okay, so this is the difference, and it was significantly, it was statistically significant if you see the p less than 0.01 by PET test. Okay, all right. So the underestimation was statistically significant as well as had strong effect size. So this is very, it's a true difference. So when you see the Cohen's D, the bigger the Cohen's means the stronger the effect of the PET test analysis. And then, okay, so we also take a look into another analytics. So in forecasting analysis, in another way of analyzing, when we do a forecast, so this is actually a forecast. We know this is a children, unknown age. Actually, we know the age, but we want to forecast. What are the forecasting age, or what are the actual age of this child? And we are using the bone left and right graph to forecast the actual age of the child. So when we do forecasting analysis, we see the difference for each child. So child 1, what are the age? 13 years old. What are the prediction? 12. So 12 minus 13 minus 1. We do one by one. We look at the deviation.